Hi guys, welcome back to PyPro versus YouTube channel where curiosity meets the code. Today we'll be discussing about how to create a GPS satellite tracking simulation. But before that, we'll be checking the packages pre-installed in my system. So the first command that I'm going to execute in command prompt is pip list, where you can see all the packages with the versions. So I can give a look about what package is what version and update it accordingly. So you can take a look onto your packages. If not installed, please do install it. You can just Google how to install and there will be a command for that to execute in command prompt. Another command to check for all these is pip freeze, which gives a similar output where packages with the version will be mentioned. So let's get started with the code, starting with all the imported modules required for this application. We have Tkinter, which is used for creating the GUI applications, and from PIL import image TK, which is used for Python image library, which is PIL, used to handle and display the images respectively. And we have also imported random, which provides tools for making random selections. Let's see the structure of the program starting with the main class of GPS application, which includes a method of init. And we have also a method of tracking the lines and draw satellite. And if you come down, you see a method of draw GPS devices. And we also have a method of move GPS devices. And we have animate tracking. And here we have communicate with satellite method. And also we have another method for updating of the tracking lines and then the execution loop. So let's go one by one, starting with init. So firstly, we have class GPS application, which defines a new class called GPS application. And then we have def in itself, comma root. This defines a constructor with self-representing the instance of the class and the root as well as the main window, which is a parent widget. And we have self.root is equal to root and self.root.title is equal to GPS1 tracking. This stores the root widget and sets the window title to GPS1 tracking, and we have self.root.geometry 600 into 800 into 600. This sets the initial size of the window to 800 into 600 pixels. And we have self.canvas is equal to tk.canvas root comma width 800 height 600 and background color is given as sky blue. This creates a canvas widget for drawing the graphics set its width height to 800 into 600 pixel and the background color to sky blue, and we have self.canvas pack which places the canvas in the window using the pack geometry manager, and we have self.satellite image which is equal to image.open satellite.png resize 30,30 image. This opens the file named satellite.png resized to 30 into 30 pixels using the high quality Lanthnos filter. And later we are having self.satellite image which is equal to image tk.photo image self.satellite image. This converts the fill image to format the Tkinter canvas. And then we have self.gps device image which is equal to image.opengps device PNG and resize it to 30 into 30 and a filter of Lantos. This similarly opens and resize the GPS device.png image, and we have self.gps device image is equal to image tk.photo image self.gps device image. This converts the PIL image to format the Tkinter canvas, which can be used. And later we have self.satellite, which is initialized with an empty list to store the satellite information. And we have self.draw satellite. This calls the method to draw the satellites on the canvas. And later we have self.draw GPS device, which calls the method to draw the GPS device on the canvas. Let's move on to the next. Moving on to the next, we have DEF tracking lines. So DF tracking line self, this defines a property called tracking lines to manage the tracking line data, and if not, has a self dot tracking lines, which is empty list. This initiates the tracking lines attribute if it doesn't exist, and we have return self dot tracking lines. This returns self dot tracking lines list. Let's move on to the next method, which is draw satellites. So as usual, it is DEF draw satellite self. This defines a method to draw satellite images on the canvas. And we have for in range 7, loop 7 times to draw 7 satellites. And we have X and Y, which is random branded 50 to 750. And Y we have given between 50 to 550. This randomly generates X and Y coordinates for satellite placement, and we have satellite is equal to self dot canvas dot create image X comma Y image is equal to self satellite image. This creates an image item on the canvas at the generated coordinates, and we have self dot satellite append X comma Y satellite. This stores the satellite coordinates and references in the list. Let's move on. So the next method is draw GPS devices. So starting with DEF draw GPS devices of self. This defines a method to draw a GPS devices, and we have self dot GPS device is equal to self dot canvas create image 400 comma 300 image is equal to self dot GPS device image, and this creates a GPS device image on the canvas at a fixed position. And we have self dot move GPS devices. This calls the method to start moving the GPS devices. Let's move on to the next function or method, which is move GPS devices. So starting with we have DF move GPS devices. Self this defines a method to move the GPS device randomly, and we have DX is equal to random choice of a couple of numbers, and DY and from -2 to +2 randomly chooses the moment of delta for x and y coordinates, and we have self dot canvas dot move self dot GPS device comma dx comma dy. This moves the GPS device image by the calculated deltas, and we have self dot update tracking lines dx comma dy. This calls the method to update the tracking lines based on the movement, and we have self dot route after 1000 comma self dot move GPS devices. This schedule this method to be called again after 1000 milliseconds, which is 1 second. Let's move on to the next method. So the next method that we are having is animate tracking. So we have DF animate tracking step. This defines a method to start the tracking animation between the satellites and the GPS devices. So we have a for loop. We have for satellite in self dot satellite. This iterates over each satellite. And we have self dot communicate with satellite. This calls the method to simulate the communication with each satellite. The next one, the next method is communicate with satellite. We have DF communicate with satellite, self dot satellite. This defines a method to simulate communication between the satellite and the GPS devices. We have satellite X, satellite Y, which is equal to satellite. And then we have GPS devices X, GPS devices Y is equal to satellite dot canvas dot parts self dot GPS device from 2. This gets the coordinates of the satellite and the GPS devices, and we have line is equal to self dot canvas dot create line satellite X satellite Y, and then GPS X GPS device Y, and filled with red and arrow to TK dot last. This draws a line from the satellite to the GPS device colored red and with an arrow at the end pointing towards the GPS device. And we have self dot tracking lines dot append line. This stores the reference to the line in the tracking lines list. So let's move on to the next method, which is updating the tracking lines. So as usual, we are having DEF updating tracking line self dot moment. This defines a method to update the position of the tracking lines after the GPS device is moved. And we have dx comma dy is equal to movement. This unpacks the movement deltas, and we have for line in self dot tracking lines iterates over each tracking line, and we have satellite X, satellite Y, GPS device X, GPS device Y is equal to self dot canvas dot coords line. This gets the current coordinates of the line endpoints, and then later we are adjusting the coordinates by the movement of the deltas, which is satellite X incrementing to dx. So this adjusts the coordinates by the movement deltas, and we have self dot canvas dot coords line comma satellite x y GPS device x and y. This updates the line coordinates on the canvas. So let's move on to the execution part. So you can see the first one is if name is equal to main, this checks if the script is being run directly. Then we have root is equal to tk.tk. This creates the main window, and we have app is equal to gps application.root. This initiates the GPS application with the main window as its root, and we have tk.button root dot text start tracking command app dot animate tracking dot pack. This creates a button that starts the tracking animation when clicked, and we have root dot main loop. This starts the Tkinter event loop to keep the application running. Thank you so much for watching. If you have learned something from this video, please do like, share, and subscribe to our channel. Thank you.